Hey y'all, today we are going to go over the last section in Module C, and you can see we're doing a combination of 3 sections from the first module, the second module, and then this module because they all fall under regression. So our essential question for today is, how do we write a linear, quadratic, or higher order polynomial equation that models real-world data? So we do this by running regressions, and we can do this all at the same time because if you know how to do linear, you know how to do quadratic, and so on. So 3 sections seems like a lot, but I think we got it. So when it comes to modeling an equation, we look at what is called the correlation. Okay. So in order to talk about correlation, we reference back to what we call a scatter plot. A scatter plot is a graph that relates 2 sets of data by plotting the data as ordered pairs. So you can use the scatter plot to determine the strength of the relationship, that's called your correlation, between the data sets. Now it says here, the closer the data points fall along a line with a positive slope, the stronger the linear relationship and stronger the positive correlation. However, there are different types of correlations that you need to be aware of, and we're going to dissect those right here with these graphs. So starting with the left, you can see that the data is going down in a linear fashion, so that would be a strong negative correlation. Because you can see here that that data follows in closely with that trend line of, oh, okay, yeah, that's going down. And they're really close together, and they look like they could almost form a line, so that's why it's a strong and negative correlation. Now, a weak negative correlation, again, if I were to draw a line here, you can see that the data is trending downward. However, it's not necessarily really close to the line that I just drew, so that's why we call it a weak negative correlation. Here in this middle one, there is no rhyme or reason to those data points, so that is no correlation. And then we're going to look at the other direction too. This would be a weak positive correlation because, again, the data is trending upward. However, those points are not necessarily real tight, close together in line. And then here, you can see the points are a lot closer to the line that I just drew. So that would be a strong positive correlation. So our goal is to find the equation that has the strongest correlation for our data. So the first thing we're going to look at is linear regression. So with linear regression, we're looking for the line of best fit, and we want to find the line that shows an accurate trend with the data. So the way that we're going to find that line of best fit, again, I'm highlighting that phrase, the line of best fit is through linear regression. Line means linear, that makes sense. All right, to find the strength, okay, to find how strong or weak, positive, negative that correlation is, we look at what's called the correlation coefficient. And that variable is represented by R. The closer that R value is to 1 or -1, the stronger the fit is. Okay? It is most accurate when it's at that 1 or -1. So for example here, down in these graphs, you can see that I have 5 points, and the linear equation, it kind of looks like it could work, but it's not exactly on it, right? A quadratic is getting a little bit closer to those points, but actually when you do a cubic regression, you can see that it fits every single point. So the cubic would be the best equation to represent that data. So down here at the bottom, you definitely need to know this discrepancy. When we do linear regression, you only look at R, but when you do every other type of regression, you look at the R squared. Okay, we want it to be 1 or -1. But for linear, you just look at R. Everything else is R squared. So how do we look at the R value? On your calculator, you have to turn your diagnostics on. So on your calculator, you're gonna get to your home screen and you're gonna go to second 0, and that brings up the catalog. And you can scroll down until you get to the word diagnostic on. Ooh, right there, diagnostic on. And then hit enter. And then you have to hit it one more time until it says done. So now when we do our regression on our calculator, we'll be able to see that correlation coefficient. You don't have to do that every time. Once you do it the first time, you're good to go. However, you definitely, if you reset your calculator, like before you take the ACT or the TN Ready, you have to, when you reset your calculator, it won't show your diagnostic on, so you're going to have to go back in and do that. All right, so let's put this into action here. Make a scatter plot of each set of points and describe the correlation. So here we have our data, and we're going to take that data and enter it in our calculator. So on your calculator, we're going to go to Stat, and we're going to hit enter because we want to edit our list. And in our list, we're going to type our X values into L1, and we're going to type our Y values into L2. So for my X values, I have 1.2, 2.5, another 2.5, 4.1, and 7.9. 4.1, and then 7.9. Okay. Now in L2, we're going to enter in our Y values. So we have 1, 6, 7.5, 11, and 19. So we want to make sure we have the same amount of X's as we do Y's, and we are good. And so from here, so right where we said go to Stat, Edit, and enter the X's into L1 and the Y's into L2. And then we're going to go to Stat Calc, and then we're going to choose our regression. So they want us to make a linear, because we're still dealing with linear. So we're going to go to Stat, we're going to go over to Calc, and we're going to choose option number 4. That says LinReg. That stands for linear regression. So what this next screen asks you is, do you want to pull your do you want your X values to be from L1? Yes, we already typed that in. Do you want your Y list to come from L2? Yes, we already typed that in. Okay. So from here, we're going to go down to Store Reg EQ. Okay. So what this is going to do is once we get our linear regression equation, it's going to store that equation into Y1. So when we graph, it's already there for us. We don't have to type it in. So if you hit vars and you go over to Y vars, and then you hit enter, enter. So it's saying, do you want me to store that equation in Y1? Yes. And then we're going to hit enter to calculate, and we have our equation. So we would have Y equals, we're going to have to write this down, Y equals 2.533x. So we have Y equals 2.533x. And then what was the rest? Negative 0.32. Negative 0.32. Okay. So now we want to look at that R value. Remember, we're doing linear, so we want to look at the R. And we notice our R value is 0.98. Our R value is 0.98. So what does that say about our linear equation here? It is almost an exact fit. So remember, we want that to be closest to 1 or negative 1. So this would represent a very strong positive correlation. All right. So now, how do we make the scatter plot? So let's go back to our calculator. And we're going to go to y equals. And you notice here is your equation that you just got from your regression. But go up to plot 1. And hit enter. And that will turn your plot on. Now, if we go to second stat plot, you'll notice that it just says, hey, you turned your plot on. So let's go into that plot and make sure that it's what we want it to look like. So it's on, and it is a scatter plot. So those are all the dots. Do you want your x to be L1 and your y to L2? Yep, that's good. So if we hit graph, you'll notice that you can see some of the points and some of that line. If you go to zoom stat, down at the bottom, it's number 9. That is fitting your data for the statistics that you entered in. So if you go to zoom 9, now you can see all of the points with your line, and it looks beautiful. So you can see how close all of those points are to fitting that line. That's why it's 0.98. If it was 1, every single point would be on that line. All right, let's try another one. So we're going to go back in our list, go to stat, go to edit, and if you want to clear out your list, just arrow at the top, hit clear, and hit enter. So arrow to the top, hit clear, and hit enter. And then we can do the same thing. We're going to type in our x's. So I have 1, 2, 3, 4, 5, 6, 7, and 8. And then in my y column, I have 55, 38, 54, 37, 53, 40, another 53, and then 36. So I have as many x's as I do y's, so I'm good there. So now let's go to stat and go over to calc. We're going to run our linear regression. Again, L1 and L2 is fine, but let's store that equation. So we're going to go to vars, go over to yvars, and hit enter, enter. And then we can calculate. So our equation is negative 1x plus 50.25. So we have y equals negative x plus 50.25. That is our equation. We're going to look at the r value to figure out how strong that relationship is. And it says it's negative 0.28. Okay, so our r value is negative 0.28. Let's graph this on the scatter plot and let's see if we could say maybe that's a weak negative correlation, or if that's no correlation at all. So go ahead and from here, you can go to y equals to make sure your equation's there, your plot is still on, and hit graph. And you notice you might not be able to see the points, so let's hit zoom 9. There we go. Anytime you can't see your scatter plot, hit zoom 9 and it'll get you there. So, as we can see here, it almost looks to me as like, it's right in between like negative, weak, like I can see where it's a little bit negative, but this is like a super, super weak correlation. I would almost beg to say that it's no correlation. Okay. All right. Let's put this into action with an application problem. Same thing, but now we're just using words, and this is what a lot of the questions are going to look like from here on out. It says the table shows the median home price in Florida. What is the equation of the trend line? Trend line. That means you are doing linear regression. That models a relationship between the home and the prices. So it says use an equation to predict the home price for 2020. Okay, so we're going to go to our calculator and we're going to edit on our stat and we're going to clear out what we got there. And we're going to type in the years for the X's and we're going to type the median price for the Y's. But I don't want to use 1940 because when we're dealing with years, we always like to start at year 0. So 1940 is year 0, so that makes 1950 10. This would be 20, 30, 40, 50, and 60. It just allows us to work with smaller numbers, and we always like that, so that's what we are going to do. So let's type in 0, 10, 20, 30, 40, 50, 60, and that's all. And then we're going to go over to the L2 column and we're going to type in 2300, 4000. Oh, that's all typing in wrong. 2300. Yep, okay, so $40,100. Okay. This is really important because if you mess up one little thing, your whole equation is going to be wrong. Like that right there. 105500. Okay. It's early on a Friday, forgive me. All right, so we have all of our data typed in. And you notice that this equation is not asking for a scatter plot. It just wants you to give them the equation. So we don't have to plot this. We just need to give them the equation. So we're going to go to Stat and go to Calc and do our linear regression. And then if you want to store the equation, you can, because I'll show you a shortcut. So if we go to vars, yvars, enter, enter, and then we can calculate. So we have our equation, and you notice looking at your correlation coefficient, it's very strong and positive, that 0.98. So let's write this equation down. I have y equals 1,411.42. Let's go to 3 decimal places, 429x, and then plus 25,114.286. Okay. So from here, we have our equation. Y equals we have 1411.429x plus 25,114.286. And so what we're going to do with that equation is now predict the home price for 2020. This goes all the way back. Why did we ever evaluate in the first place, right? So we can do this right here too. 2020 would be the year, right? So I got like 2010 and then 2020. So instead of plugging in 2020 for my X, I need to plug in, what would 2020 be from 1940? That would be 80 years, right? So all we're going to do is plug in 80 for X, and let's see what that gives us. And that'll be our prediction. Oh. So we're going to go to second quit, go back to the home page, and we type in 1411.429. times 80 plus 25114.286. So we can expect the median home price to be $138,028.61. We're dealing with money, so we can round up. Perfect. All right. Let's try one more, and then this will be the end of part 1. If you want to try this on your own, I really encourage you to pause the video and try it. If you need to follow along, please feel free to do so. So we have to go back to Stat and Edit, and we're going to clear out what we have there. And again, we want our years to represent, we're going to start at 0. So we're going to say this is 0, this would be 2, 4, 6, 8, and 10 years. So let's pull that up. So we would start with 0, 2, 4, 6, 8. And did I go to 10? Yes. Miss Jones, it is a Friday, is it not? Lord help me. Okay, so we got 2.57, 2.83, 2.93, 2.93, 3.10, and 3.71. Okay, so now we're going to run our regression. So go to Stat, go over to Calc, option number 4. And then you don't have to store the Reg EQ. I decided not to show you all the shortcut because it's a lot of buttons on here and you can just plug in. It's really not that big of a deal. So go ahead and hit Calculate. And let's write that equation down. So we get y equals 0.093x plus 2.54. Let's round that up to 7 because that's 6 repeating. And you'll notice that your R value is 0.90, so that's still pretty strong. It's really, really strong and positive. So now we're going to answer the question. We have our model. We said it was y equals 0.093x plus 2.547. And then it wants us to predict the price of milk in 2025. So to predict for 2025, we need to look at, okay, we started at year 0 with 1998. So how many years has it been from 1998 to 2025? That would be 17 years. So I'm going to plug in 17 for x. And we're going to figure out the price of milk for the year 2025. So let's go to the home screen. I have 0.093 times 17 plus 2.547. So it says milk will be $4 and that would round up to 13 cents. I think we already pay that now. Some of us, maybe. Depends on what milk you get. Perfect. All right, that is the end of part 1. Feel free to stop and take a break, and then we'll pick the rest up with part 2.